Hello my dears, how are you all? So in the last class we discussed some concept of rotating magnetic field. It's very important my dears. It's very important because whenever you want to know the basics, if you really know the basics of the subject, actually for examination point of view you need just some equations and you have to solve some problems, okay, but that's only for exam. But as an electrical engineer, you have to know the basics, that is the reason why I took that rotating field, that is the effect of a rotating magnetic field, because that is the basic principle of an induction motor. I can simply say there is a rotating magnetic field around this stator and it is rotating at a speed of ns, that is the synchronous speed. I can say like that, but you want to know the complete knowledge about that, why that or how that rotating magnetic field is arise, or what is the reason behind that, okay, what is the peculiarity of that rotating magnetic field, that all detail you should know. Then only in future or in interview, someone ask you how or the induction motor runs, okay, you have to explain, right? You have to explain. So today we are going to do some important problems regarding the induction motors, okay. So please write a question. Through questions also we will learn a lot of things, my dears. So in theoretical session there is a limitation, but doing problems, in between those problems there are so many questions, there are so many concepts we have to learn, okay. So we will learn one by one. Write a question. The rotor power output of a three-phase induction motor is 15 kilowatt. The copper loss at a slip of 4% will be what? Listen my dears. So the rotor power output of a three-phase induction motor is 15 kilowatt. The copper loss at a slip of 4% will be what? That is our question. So see, focus on the rotor. Okay, this is my rotor. Here the input power is nothing but the PG, and the rotor copper loss, that is the minus that rotor copper loss. Rotor copper loss is nothing but S into PG. Is it correct? PG and S into PG will be the rotor copper loss. I already explained that, Yes, the relation between copper loss and PG, you already know that. So this is nothing but PCR, right? Or PRC, rotor copper loss. PRC is nothing but S into PG. And after that, there is what? PM. That is nothing but mechanical power developed, PMD. The mechanical power developed, that is the rotor output. And from this mechanical power developed, we gave the input power, or there will be some losses, rotor copper losses, and after that the current entered into or inside the rotor, right? Due to that journey, or while that journey, there will be some rotor copper loss inside the rotor terminal, I mean rotor bar or rotor, simply rotor. So inside it is inside, right? See, this is the rotor, right? Imagine this is the rotor. So many conductors are there, my dear. So many conductors are there inside the rotor. You gave the supply as PG. You gave the supply or input power as PG, and due to this there is a current which is flowing inside this whole conductor, right? So there will be so many losses in the copper conductor. That is nothing but S into PG losses. After that, here it is shaft conductor, here it is shaft connected. So after all those copper losses, the inside shaft, no, inside or the copper core or the inside of the copper, no, there a power developed. That power is nothing but a PMD or the mechanical power developed in the rotor. That is a rotor output actually. And from this rotor output, there will be what? There will be some friction and windage losses. Okay, and after that only there will be shaft power. Shaft power means the power available here, that is the shaft power. That is the shaft power. The idea is clear to you? The idea is clear, my dears? So we gave the power. Please imagine these things in your mind. Okay, then only this problem can be solved. Simply knowing some equations, we can't solve this problem. We have to know clearly what happening there. What is the exact meaning of each term? You have to know. See, the power input to the rotor is PG. So there will be some losses. These losses are called, these losses is nothing but S into PG losses will be there. After that there will be some power developed, that is called mechanical power developed, that is the rotor output actually. Rotor, simply the rotor output. And after, this is the rotor and this is the shaft, my dear. This is the shaft. This is the rotor and this is the shaft. Here it is, we connected the load. Here only we connected the load in the machine, in the motor. So from the developed point, it has to turn the load, no? So it have to overcome the frictional, the weight of the shaft, the windage effect, etc., etc. It have to overcome. So the developed power here will not be equal to the shaft power here. Clear? It will be different small amount by small amount, because these minus what? Friction and windage losses. Friction and windage loss. I already told you what is meant by windage loss. The losses due to the air resistance, that is called as windage losses. Windage losses will give the value of what? P shaft. Will give the value of what? P shaft. This term you have to clearly know. Clear? So P shaft is nothing but the available, the total, that means the what? The far end of the motor, there will be the load, right? There will be the load. That means the power which is directly available to the load is called the shaft power. The power which is directly available to the rotor output is called the rotor output power, or PMD, or mechanically developed power. These diagram, no my dears, these diagram will be very, very helpful to you. These diagram will be very, very helpful to you for solving so many problems in very short time. No, this diagram is very, very helpful. Okay, so this is the concept. Again, come back to our questions. What is that? Come back to our question. What is that? Let's come back to our question. The rotor power output of a three-phase induction motor. Rotor power output is nothing but, my dears, what is that? PMD, correct? It is nothing but what? 15 kilowatt, correct? The copper loss at a slip of 4% will be, so slip will be equal to 4%, or simply what, my dears? 4 by 100. Simply 4 by 100, or it will be 2 by 50 or 1 by 25, correct? 4 by 100 is nothing but 1 by 25. Okay, so what we have to find? The rotor power output, right? So we have to the copper loss, no? We have to find the copper loss, rotor copper loss. PRC we have to find. What is the equation for PRC? What is the equation for PRC, my dears? PRC, there is a relationship, no? What is that? There is a relationship between PRC and what? PMD, no? PRC divided by PMD is equal to S divided by 1 minus S. Correct? Correct? It will be equal to what? S is nothing but 1 by 25 whole divided by 1 minus 1 by 25, correct? So PRC, we have to find what? PRC. PRC will be equal to PMD. PMD is given by 15 kilowatt. So 15,000 into, what is that? 1 by 25, right? 1 by 25 into 24 by 25, correct? Correct, my dears? So it will be cancelled. So 25 and 25 it can cancel, correct? And 15,000 divided by 24, right? 15,000 divided by 24. Let's find that. Let's find that. First we have to find 150 by 24, what it is. 150 by 24, what will be? 24 into 6, what it be? 24 into 6 will be 144, 6, correct? So again 2 zeros are there, right? So 2 zeros, it will be 2 zeros. 24 into 60, how many? No. That 2. 48, right? Again 24 into 24. Correct. 5. Okay. So the answer will be what, my dear? 625 watt. 625 watt. That is the rotor copper loss. Is it clear? Is it clear? The rotor power output of a 3-phase induction motor is 15 kilowatt, means this PMD, that is the rotor power output. Rotor output is nothing but PMD. Shaft power is alag, it is different. It is different from the rotor power output. Shaft power is different, my dears. Shaft power is actually different. Okay. So this picture now, this picture always should be in your mind. Always should be in your mind, this picture. Then only problem can be solved easily. Problem can be solved easily. Otherwise, you may stuck somewhere. Okay. You can't move. You can't move. Is it clear? Can we go to next problem? Okay. This PRC is nothing but rotor copper loss, correct? Okay, let's do next question. In an induction motor, what is the ratio of rotor copper loss and rotor input? Actually, this is not at all a question for us now, correct? In an induction motor, what is the ratio of rotor copper loss, right? Rotor copper loss is nothing but, my dear, PRC divided by rotor copper loss, and rotor input is nothing but, my dear, PG. What is that? Simply yes, correct? Simply yes. The answer will be yes. This type of question may be seen in examination. Direct question, simple answer, but you have to think, right? You have to think. Write another question, my dears. Write another question. A 3-phase 6-pole a 3-phase 6-pole 50 hertz induction motor 50 hertz induction motor delivers 3.73 kilowatt at 950 rpm. What is the stator input? What is the stator input if the loss is, if the stator loss is 250 watt? If the stator Loss is 250 watt. See, my dears, read the question. Read the question carefully. Read the question carefully. What it actually says. What it actually says. See, a 3-phase 6-pole 50 Hz induction motor delivers 3.73 kilowatt, right? At 950 RPM. At 950 RPM, it delivers 3.73 kilowatt. It delivers means, what is that? What is that? What is that? In our diagram, it delivers means what, my dears? It is simply PMD, right? It's simply rotor power output. It is delivering. But the load in the receiver end, no, it may or may not receive the whole power, depending upon the shaft efficiency, depending upon the friction. It may or may not get the same power or not. That's not our concern. But it is delivering. The rotor is delivering. Are you ready to receive the whole power? Then arrange your shaft properly. Then make the wind resistance as low as possible. Then make the friction loss as low as possible. Then the delivered power. Suppose I am the delivered power. I am at my rotor side now. There is my load. If I want to go completely there, then my losses should be very less. My losses will be minimum. Then only I can go maximum to the load side. Correct? So in this figure, in this problem, maximum power delivers means, which is nothing but, my dears, rotor output, which is nothing but the developed mechanical power bus. Correct? Rotor output is nothing but developed mechanical power. Correct? So that is nothing but what? That is nothing but 3.73 kilowatt, or, my dears, it is nothing but 3730, correct, watt. 3730 watts at 950 RPM. So NR, or simply N will be equal to what, my dears? 950 RPM, correct? 950 RPM. What is the stator input? If the stator loss is 250 watt, so stator loss is given by what, my dears? 250 watt, correct? We have to find what? Stator input. We have to find what? Stator input. What is stator input actually? Stator input will be equal to, first you have to write the question itself. Stator input will be equal to what, my dear? Stator output plus stator loss, correct? Stator loss. Stator output is nothing but rotor input, correct? Stator output is nothing but, my dear, rotor input, am I right? Stator output is nothing but the input to the rotor, correct? So stator output will be equal to rotor input plus stator losses, correct, my dears? So we have to find first rotor input. Stator losses is already given now. Stator loss is already given as 250 volt. So only our aim is to find what? Rotor input bus. How can we find rotor input? We have the relation, my dears. Rotor output by what? That rotor input will be equal to 1 minus s. Am I correct? Rotor output by rotor input equal to 1 minus s. And also I gave another equation which is nothing but n by ns. Correct or not? N by ns. Correct or not? I gave that equation too, right? I gave that equation too. Because rotor output is proportional to the rotor speed and rotor input power is proportional to the synchronous speed, correct? So it will be n by ns, correct? What is ns here? What is ns here? 120 Fs by P. Am I correct? 120 Fs by P. So it is nothing but 120 into Fs is what, my dears? Fs is nothing but the supply frequency. It is nothing but 50 whole divided by what is P? P is nothing but 6 pole, right? So it will be 6. So 20. So it will be 1000 RPM. So you got ns as 1000 RPM. That is the synchronous speed. What is n? N is already given, no? N is already given. It is nothing but 950. Correct? Correct? So directly you can substitute here, my dears. Rotor output by rotor input equal to what? 950 divided by 1000. Correct? 950 by 1000. Okay, can I rub the first problem? Okay, so you have what we have to find actually? Rotor input, right? We have to find rotor input, correct? So rotor input will be equal to what, my dears? Rotor output into 1000 divided by, right, divided by 950, correct? Which is equal to, what is the rotor output? It is given 3730, correct? Into 1000 by 950. 5, what it will be? You can cross multiply, okay? You can do 3930. Answer will be 3930 watt. Okay, you can do manually. Okay, no issues there. And what is our aim, idea? Stator input, right? So what is the stator input? That is, stator input will be equal to, what is that? Rotor input parts, that is 3930 plus stator losses is nothing but 250, correct? Correct? 3930 plus 250. Your answer will be 4180 watt. 4180 watt. This is the final answer. This is the final answer. See, if you really know the concept only, you will solve. You can solve this problem. Otherwise, it will be. See, very big problems. No, very big problems are there. Very big problems are there. But not. It may not be asked. It won't be asked, right? It won't be asked because that type of question. No, it is not for the examination like. AEJ examination. The gate may be the alag part. The gate, no, it is different. So there is a chance of asking those type of questions. But in SSC JE, RRB JE or state level AEJ examination, sub-engineer examination, no, these type of questions will not be asked. Okay, so this type of question will be asked. Not big question, but this type of question will be asked. Because this is, if you know the concept, this is two-step answer, no? If this is a two-step answer. So take care of these questions. Okay. Actually, my aim is to first complete the syllabus and do maximum problem in the class itself. After that, we have to solve previous year question paper. That to what? That to subject wise. We will do previous year question paper, that to subject wise. Definitely, we will get time. I will do my level best, and you have to support me. Okay, you have to support me. Then only I can do. So first of all, we have to finish the syllabus. So circuit theory we finished, machines we almost midway. So circuit theory, machines, power system, measurements, 4 important topics. It may cover nearly 70 to 75 questions, 70 to 75% of questions. No, so if you complete these, definitely we will go to previous year question paper. In previous year question paper, we will do all state AE, JE previous year questions. All state JEE previous year important question we will do. We will give you homeworks also. Okay. Actively we can move. Okay. Actively we can move. And after that, what? That means that is along with the revision, my dears. That is along with the revision. Okay. And after that, if you get the time, we will go for some very rare topics. Very rare topic we can go. No, we will go definitely. So. And one more thing I want to tell you, don't wait for the last moment, my dears. Don't wait for the last moment. If you are seriously preparing for some examination, definitely for electrical, I will definitely tell you, it definitely takes 6 to 7 months of hard work. Then only you will have a good knowledge of your subject. You can't grab it by simply 2 or 3 months. You can't grab it. Because it's a 4-year course, my dears. In 4 years you studied all these things. So how can we concentrate to even 2 to 3 months? Even if you studied, it is simply you can say, okay, I studied. But you can't solve a single problem. You can't solve that. Because you just know a peripheral idea will be there. That won't work in the examination. So you need a dedicated study. So don't wait for, tell to your friend that no, I'm putting my video for regular basis, nearly 1 hour basis I am putting my videos, but the viewers is very less, but the subscribers are no, it is okay, 263 subscribers are there, but the viewers no, maximum 15 or 20 viewers are there regularly. It is not good. Don't wait for the last moment. You can't grab. Definitely, I'm telling you seriously. You can't pick up to that level in 2 months or 3 months. It needs 6 to 7 months of hard work plus the previous year question paper analysis. Then only you will be at a level. So it needs nearly 9 months, nearly 7 to 8 to 9 months hard work. Then only it will be cracked. Is it clear, my dears? So don't wait for the last minute. Okay, whenever the notification came, I will come. Whenever the notification come, I will study. Do not wait for that last moment. Okay, so start your preparation. So let's do another question. Very, very important question. Okay, the input to a three-phase induction motor is 50 kilowatt, comma, the stator loss amount to be the stator loss amount to be 800 watt. The rotor copper loss per phase is, comma, S is equal to 0.03 and after that comma, what is the PMD or developed mechanical power. Okay, how can we solve this, my dears? Listen, read the question. The input to a three-phase induction motor is 50 kilowatt, right? 50 kilowatt. That is nothing but, my dears, stator input, correct? Stator input is nothing but 50 kilowatt or 50 watt, correct? The stator loss amount to be 800 watt. So the stator output will be what, my dears? Stator output will be stator input minus losses, am I correct? Which is equal to 50,000 minus 800, which is nothing but, yes, 49,200 watt, correct? 49,200 watt, correct? Am I correct? Yes. So that is a stator output, correct? The rotor copper loss per phase you have to find, right? So what is rotor copper loss? Equal to what? PRC, correct? Equal to what? PRC we have to find. PRC you have to find, correct? So stator output is nothing but rotor input, am I correct? Stator output is nothing but rotor input. PG, which is nothing but 49200, correct? Okay. So what is S here? S is nothing but 0.03, or I can simply say 3 by 100, correct? 3 by 100, my dears, 3 by 100. So what is rotor copper loss or PRC? There is an equation connecting PRC and PG is equal to PRC by PG will be equal to simply S, my dears, simply S. So that PRC will be equal to what? S into PG, correct? Which is equal to 3 by 100 into PG. PG is nothing but 49200. This 00 and this 00 cancel. 492 divided into 2, 3. 492 into 3, my dears, 6. (1476 watt). So that is the rotor copper loss. But the answer is not that. But the answer is what? Rotor copper loss per phase you have to find. Correct? Rotor copper loss per phase you have to find. Correct? It will be equal to what, my dears? 1476. Correct? 1476 divided by 3 per phase you have to find. No? So the total, this is the 3-phase rotor copper loss, my dears. This is the 3-phase rotor copper loss. So you have to find what? Per phase value. So for getting that per phase value, you have to simply divide by 3. That's all. You have to simply divide by 3. That's all. So what will be? 1476 by 3. What will be? Nearly what? 1476 by 3. What will be that? 492. Am I correct? Am I correct? 492. Correct? So it will be equal to what? 492 watt. Correct? Okay. Our question finished or not? No. What is the PMD? PMD is nothing but, my dears, rotor output. Correct? PMD is nothing but simply rotor output or the developed mechanical power. So PMD will be equal to what? Rotor output simply equal to rotor input minus what? Rotor copper loss. Correct? Rotor output will be equal to PMD. PMD is nothing but the input. Rotor input is nothing but PG or the air gap power. PG minus PRC is nothing but the rotor copper loss. You have both. You have both, right? So what is PG? What is PG? 49200. Correct? 49200 minus. What is, my dears? PRC is what? 492. Correct? 4900 minus 492. No, it's not 492. It is a per phase value, no? It is not the. You have to calculate for full PRC. You have to calculate 1476. 1476. Sorry. That is the rotor copper loss. So the answer will be 47724. So that is the PMD. That is the PMD. Sometimes the answer may be in HP, horsepower. So, but you have to convert these to horsepower. How can we convert? We know 1 horsepower will be equal to what? 746 watt. 1 horsepower will be equal to what? 746 watt. So this is how much horsepower? So simply PMD in HP, horsepower will be equal to what, my dears? It is 47724 divided by 746, simply nearly equal to 64 HP. Nearly equal to 64 HP. You can solve that. Okay, you can solve. In examination, this much difficulty means this much cutting difficulty will not be there. There will be easy questions. You can easily cut the values and you will get the HP value. Okay, that type of parameter will be in numerator and denominator. Focus the question. Is there any doubt in the question? You can ask in your comment section. No issue. No issue, my dears. No issue. Okay. And I think you may get bored somewhere in between, right? You may feel asleep. You may fall asleep. No. This is due to the fact that I already told you the reason. You are watching. Suppose you are watching this video after the lunch. Definitely you will be fall asleep. No doubt in that. It's not my problem or it's not your problem. It's the problem of our body. Okay. After the lunch, our body will be very hard struggle to digest the food. So it may not be focused on the brain area. I mean the studying area and all. The body will not accept that. The body is focusing on the digestion, right? Digestion. So it's not your fault. So the best time or the ideal time for the study purpose is that morning 5 o'clock or 4 o'clock, or after 10 to 11, no, 10 o'clock. No? Suppose you had your dinner by 8 o'clock or 7:30 or 8 o'clock, then 8 to 9, 9 and a half, no, 9:30, after 9:30 your stomach will be completely free. Free means it is from work free, so you can easily focus after 9:30 or 10 o'clock. It will be easy. So anyway, adjust your time and study. It's your duty now. You have to get a job, right? So you have to work hard. You have to work hard, my dears. Okay. Write another super question. A 3-phase induction motor, a 440 volt 3-phase induction motor, 50 hertz, 6 pole. Input to the rotor is 18 kilowatt and rotor EMF is 100 revolution per minute. Find A, rotor frequency, B, mechanical power developed, and C, rotor copper loss. See, this is B. This is B, right? This is. You can take this as B. This as B. Okay. Mechanical power developed. And D, rotor efficiency. And E, rotor speed. See, like a single question, how many sub questions are there? So how many sub questions are there in a single question? See the question, read the question very carefully. A 440 watt 3-phase induction motor, 50 hertz. So Fs will be, of course, what? 50 hertz. Number of poles P will be 6 pole, right? 6 pole. Input to the rotor is nothing but 18 kilowatt. Input to the rotor is nothing but, my dears, Pg is equal to 18 kilowatt, correct? 18 kilowatt. And rotor EMF is 100 revolution per minute. The EMF is not in volt. The EMF nature is 100 revolution per minute, my dears. So EMF nature is nothing but the frequency of the rotor, correct? The rotor EMF is 100 revolutions per minute means the rotor frequency is what? 100 by 60 seconds, correct? That means that much hertz, right? That much hertz. So it will be equal to 5 by 3 hertz. So the rotor frequency is directly what? 5 by 3 hertz. That is the first answer. That is the first question. Rotor frequency is nothing but what? 100 by 60 or simply 5 by 3 hertz. Next, what is the second? What is the second? A rotor copper loss. Rotor copper loss. How can we find rotor copper loss? How can we find rotor copper loss? There is a relationship. The input of the rotor is directly what? PG, and there is a relationship as PCR, or the rotor copper loss is nothing but PRC, right? PRC, rotor copper loss is nothing but S into PG, correct? PRC is nothing but S into PG, right? S into PG. This is very useful equation, no? One more equation, PRC by PMD will be equal to S divided by 1 minus S, no? That is rarely used, but this, no, PRC and PG is, no, that is very popularly used equation. That is very popularly used. So we have to find what? S, right? We have the value of S, PG, no, PG is there, but we don't have the value of S. So first we have to find S. S will be equal to what, my dear? FR by FS, correct? Because FR will be equal to S into FS now. FR, rotor frequency, will be equal to slip times supply frequency, right? So S will be simply FR by FS. So FR is nothing but what? 5 by 3. FS is nothing but 50. So the answer will be 1 by 30. That is the slip. So that is the slip. So PRC will be equal to what? PRC will be equal to 1 by 30 into PG is what? How much? 18 kilowatt. 18 kilowatt means 8,000 watt, 18,000 watt. So 0 and 0 get cancelled, 3, 6, correct? So it will be 600 watt. So that is the answer for PRC. That is the answer for PRC. That is the answer for PRC. Next, what is next? What is next? What is next? You have to find mechanical power developed, right? Again, what is that? PMD, correct? Mechanical power developed or PMD. There is an equation for PMD. What is that equation? What is that equation? There is an equation for PMD. What is that? There is a relationship that PRC by PMD will be equal to what? S divided by, or simply you can find rotor copper loss is there, rotor input is there. Then what? Developed mechanical power is easy, no? No need to that equation. No need to that write to that equation. You can simply go for this. Developed mechanical power is nothing but what? Rotor input minus rotor copper loss, correct? Rotor input is there, rotor copper loss is there, so it will be 17,400 watt. Or you can go for PRC by PMD is equal to S divided by 1 minus. That also you can use, no issue. Anyway you can do. Anyway you can do. Is it clear? Is it clear? What is next? Rotor efficiency, correct? Next you have to find rotor efficiency. Next you have to find what, my dear, rotor efficiency. So fourth will be what? Rotor efficiency. So what is the equation for rotor efficiency? Percentage efficiency of rotor. Percentage efficiency of rotor will be equal to what? Rotor will be equal to what? 1 minus S, correct? Approximate efficiency is 1 minus S. You can use wherever it is into 100, correct? So it may be, S is what, my dear? 1 by, what is S? Slip is 65 by 3, right? 5 note is that is frequency. But what was the value of slip? I forgot. What was the value of slip? Yes, 1 by 30, correct? So 1 minus 1 by 30 into 100 is equal to 29 by 30 into 100. So these answers get cancelled. 29 by 3 into 10, you will get 96.7. So that is the rotor efficiency. Percentage efficiency of rotor. Okay. 1 minus S you can use percentage efficiency of rotor. Okay. Next. What is the next question? Sub question. Rotor speed, my dears, rotor speed. Rotor speed. How can we find rotor speed? How can we find rotor speed? Using slip you can find, and it is nothing but 1 minus s into n s, correct? Same equation for omega also, right? Omega equal to 1 minus s into omega s. So it will be 1 minus 1 by 30 into ns. Synchronous speed is what? Synchronous speed is what? We have to find synchronous speed, correct? So ns will be equal to 120 into fs by p, which is equal to 120 into fs is nothing but 50 divided by p is 6 right? 6. So 20. So it will be 1000 rpm, correct? So ns will be equal to 1000 rpm. So it will be 29 by 30 into 1000. So similarly 29 by 30 into 1000. It is 1000, correct? 191 will be answer. So 967 nearly 9, because it is 96.7 now. So one more 0 is there, so it will make 967 rpm. See the question very carefully, my dears. See the question very carefully. Note it down. Is there any doubt you can ask? Is there any doubt you can ask? These questions are very, very important. These questions are very, very important. These questions are very, very important. Feel the subject, feel the concept, feel the problem, then do. Then only it will be correct. Okay. We are not simply focused on theory, we are focused on problem also. Correct? Sufficient problems now we are doing in the class itself. This is not enough actually, you have to do more and more. How much problem you do, that will definitely beneficiary. A super question is you want to do. This question may be asked definitely. A super question is going to do very, very important. Very, very, very important question is this. A 3-phase induction motor is supplied from stator by 50 hertz frequency, 50 hertz frequency, comma, and also supplied by 60 hertz frequency. From rotor side. Full stop. At what speed rotor of induction motor rotate? Rotor of induction motor rotates, and find the direction. What a superb question. What a superb question is this? Did you get any idea? How can we proceed with at least? From where we can start? Did you get any idea? A 3-phase induction motor is supplied from a stator by 50 hertz sample frequency. That means. So suppose this is my stator, my dears. This is my stator. Okay, simply stator, and this is my rotor. This is my rotor. So here you are supplying with 50 hertz. This is my rotor now. This is my rotor. This is my stator. And here you are supplied with what? 60 hertz. So what will be the effective direction of rotation of the rotor and what will be the speed, that's we have to find. A three-phase induction motor is energized from both sides, right? Both the side you are energized from both. Stator also we gave supply with 50 hertz some voltage, and rotor also we gave some supply with 60 hertz and some voltage. And our question is what will be the direction of the rotor finally, in what direction? What direction? How can we do that? How can we do that? See, listen carefully. So from the stator, by observing the stator side, you may have a synchronous speed, let be ns1. That is nothing but the stator rotating magnetic field speed, that is nothing but the ns1. ns1 is nothing but, my dears, 120 into fs1 divided by p, correct? 120 into fs by p. This number of poles is there. Yes, one rotor poles equal to 1. Rotor poles and stator poles, okay. Two. That also you have to add. Rotor poles and stator poles equal to 2. Okay. Add that too. So it will be equal to ns1 will be equal to 120 into fs is nothing but, my dears, 50 divided by p is nothing but 2. So it will be 3000 rpm, correct? That is the ns1. That is from the rotor stator sides, okay? By observing the rotor side, the rotor also contains the same type of winding. Stator contains a stator core plus winding, rotor also containing a rotor core plus winding, no? Similar structure is there, similar structure. Stator and rotor, but one is moving and other is fixed. That is the only difference, my dears. That is the only difference. So let be ns2 be the rotor side consideration. So it will be equal to 120 into fs2 divided by p. It will be equal to 120 into what is fs2? 60 divided by p is again 2. So 60. So it will be equal to 3600 rpm. So that is nothing but ns2. That is nothing but ns2. So this is ns1. Now observe. Observe, my dears, observe. That means the rotor frequency or the rotor supplies, due to that 50 hertz, the rotor magnetic field, the stator rotating magnetic field have a speed of 3000 rpm. That means the stator rotating magnetic field will be at a speed of what? 3000 rpm, and the rotor rotating magnetic field is at a speed of what? 3600 rpm. 3600 rpm. So definitely there will be a speed difference, no? There will be a speed difference. So what is the difference here? 600 rpm will be the difference, correct? So whenever there is a difference, what happens? There will be some flux cut on some surfaces, right? If both are 3000 rpm, then there will not be any flux cut, because I am moving with 3000, the other also, rotor also. See, suppose I am the stator and other side is you are the rotor. So me and you are moving in same direction with the same speed, means there will not be any flux cut between us, correct? There will not be any flux cut between us. That means suppose this rotor also in 3000 rpm means there will not be any flux cut in between. But here it is, one is 3600 rpm means this is faster than this rotating magnetic field. That means there will be some flux cut due to this extra 600 rpm speed on what, my dears? On stator side. Rotor is more faster than the stator, so more flux cut will offered by the rotor to the stator because he is more faster, right? What was the working of induction motor? If the stator is high speed and the rotor I am simply sitting, that is the time at which me have maximum flux linkage, I am start rotating. That was the direction sorry, that was the principle of what a rotating magnetic field, sorry, that was the principle of induction motor working. Similarly, one is slow and other is fast, mean the faster will apply some flux linkages on the slower. The faster will apply some flux linkages on the what? Lower side. Similarly, this rotor will apply, the rotor will mean the rotor magnetic field will apply some flux linkages on what? The stator side. So there is a chance of induced EMF in what? Stator winding, because stator winding feel more flux linkages from the rotor side. It may cut the magnetic conductors in the stator. It may cut the conductors in the stator. The magnetic lines of force will cut the conductors in the stator. So there is a possibility of induced EMF in the what? Stator, my dear. Stator, there will be a induced EMF in the stator. That induced EMF is due to that extra 600 speed, right? That extra 600 speed is the reason for what? These flux linkage. So these induced EMF will try to oppose the reason. These induced EMF will try to what? Oppose the reason. That means the stator will start. Just assume the stator will start overspeed by 600 rpm. Then only he can compensate. The stator will start trying to overspeed by 600 rpm. Then only that flux linkage will be vanished. So he will try to catch up 600 rpm more speed than now. Correct? He will what? Acquire. He will start acquire a speed of 600 rpm more than now. Then only that rotor side flux will be compensated. But the stator is fixed. The stator is fixed or rigid. It can't move. My dears. It can't move. But due to that effect, the stator is 600 moving faster is similar to the rotor is moving backward 600. Am I correct? See, you are there and I am here. I am moving 2 meter front is similar to you are moving 2 meter back. Is it correct? I am moving towards similar. Suppose I can't move means you may move what? 2 meter back also. Then also there will be a 2 meter difference between us, correct? 2 meter difference between us. Am I correct? That means similar case, the stator is stationary, it can't rotate, but it assumed to be rotate 600 rpm more means the rotor should fall back by 600 rpm. The rotor will rotate in opposite direction by 600 rpm, my dears. This is very important concept. This is very important concept. It's very difficult to understand. You have to imagine, then only it will be get. But if you correctly know the concept, first instant you will get the answer. Otherwise you have to what? Boil your head. Then only it will be get. Then only you will get the answer. Okay, I will say once more. The stator is 300 rpm, 3000 rpm. The rotor is 3600 rpm according to the frequencies. So it is clear that the rotor is faster than the stator. I am saying rotor, stator means rotor magnetic field and stator magnetic field, not the rotor and stator, my dears. Okay, magnetic fields. It's a magnetic field, not the rotor and stator. Rotor and stator are initially standstill condition. Okay, so it is 3000 rpm and it is 3600 rpm. That means the rotor is faster than the stator by 600 rpm. That fastering process, that faster process will what? Induce some induced EMF on the stator side, because the stator is continuously acted by the increased speed 600 rpm fluxes, correct? So there will be an induced EMF in the stator. That induced EMF, according to Faraday's laws of electromagnetic induction, that induced EMF will always try to oppose the cause. Here the cause is what, my dears? Here the cause is what? Someone is forwarding me like 600 rpm speed. Someone is forwarding me. Someone is move faster than me with 600 rpm. So I have to catch up the speed of that 600 rpm. Then only that reason will be vanished. That reason will not be there. So I have to move by 600 rpm more speed. But I am stuck because someone is holding me, because I am a stator. No, someone is holding me. No, I am a stator. No, I am screwed somewhere else. I am screwed on the ground, so I can't move. So I am like rigid position. So what I will do? I will intend, or I will make to forcefully rotate the rotor in 600 rpm backward. That is also similar. I am moving forward 600 is similar to someone is moving backward 600 rpm. Its same effect will be there. Then also that speed will not be there, no. That speed will not be there, no. Or you can simple manner, my dear. Simple manner you can simple. This is 3000 rpm. The effective this side also should be 3000 rpm. Then only there will not be any cross linkage of fluxes, correct? Cross linkage of fluxes. So this is 3600 rpm right side. So in order to make this is also 3000. 600 rpm backward should be there, no. 600 rpm backward should be there, no. That is 600 rpm backward. In this way also you can think. So our answer will be what? What speed the rotor of induction motor rotate? The induction motor rotor will rotate 600 rpm in anti-clockwise direction. In anti-clockwise direction. Because this is in clockwise, this is clockwise, but is opposite direction. That is the answer. That is the answer. Is it clear, my dears? Is it clear? How beautiful question is this? What a beautiful question is this? You have to think a lot. Then only it will be answered. You can easily mug up the answer, my dears. You can easily mug up the answer. Whenever examination paper, you can see, you can directly substitute these mug up values, but not the correct way. You have to clearly know the fact. You have to clearly know the fact. I'm sure these concepts, no, it will not be in any book. It will not be in any book. They will simply like NS1, NS2 and the final. This will be right. They won't say the direction. They won't say the reason. They won't say the Faraday's laws effect and all. They won't say. They won't say. In any book you can refer. In any book you can refer. Is it clear? This is by the experience. This is by the analysis. I mean deep understanding, feeling. That feeling only give you the answer like this. Okay? You will get, definitely you will get answers from book. You will not get feel. You will not get feel from the book. Definitely. Okay? So that's all for today, my dears. So with more energy, we will meet you tomorrow. So until then, bye.